Let's consider an ideal transformer, focusing on how loads are reflected across the transformer. We'll explore different scenarios involving primary and secondary windings and how impedance is transformed. Imagine a transformer with a primary winding having a certain number of turns, we'll call that N, and it has two secondary windings, each also with N turns. In the first scenario, each secondary winding is connected to a different load. One secondary is connected to an impedance, which we will label Z1, and the other secondary is connected to an impedance Z2. The question is, what impedance does the primary winding see, or what is the reflected load back to the primary? Because both secondaries have the same number of turns as the primary, N, they each reflect their respective load with a turns ratio of 1:1. Since the two secondaries are independent, the total reflected load is the parallel combination of these individual reflected impedances. Mathematically, the total reflected load is equal to Z1 in parallel with Z2, which equals Z1 multiplied by Z2, all divided by Z1 plus Z2. Now, for the second scenario, we connect the two secondary windings in series. Each secondary is still connected to its respective load, Z1 and Z2, and both loads are still in their place. However, the secondaries are now in series. In this case, the secondary windings are adding their voltages in series, and the total reflected impedance changes. Because we effectively have twice the turns in the secondary relative to a single secondary, or equivalently twice the voltage across the series combination compared to a single secondary, the reflected impedance is now 4 times the original parallel combination. More precisely, the reflected load becomes 4 multiplied by Z1 multiplied by Z2, all divided by the quantity Z1 plus Z2. For the third scenario, consider disconnecting the load Z1 and Z2 from the center tap of the series connected secondaries, but leaving Z1 and Z2 connected in series with each other. This is a crucial change. Now, the total secondary impedance is simply the sum of the individual impedances. Since the combined impedance Z1 plus Z2 is connected to the two secondaries in series, which has the same number of turns as the primary, the reflected load is simply the sum of the two impedances. The reflected load is therefore equal to Z1 plus Z2. These examples illustrate how connecting loads differently on the secondary side of a transformer drastically alters the reflected impedance on the primary side. It highlights the transformer's capability to transform impedance levels and the importance of understanding winding configurations and load connections.